In the race for AI supremacy, Nvidia has been the undisputed king. Their chips turned abstract neural networks into a trillion-dollar reality, fueling the explosive growth of the entire machine learning empire. The industry generally treats this process like a sprint. This initial phase, called training, is when a model is built from scratch, a high-intensity burst of compute that most companies view as their primary hurdle. General-purpose GPUs are perfectly designed for this phase. Their high-throughput architecture acts like a Swiss Army knife, providing the extreme flexibility needed to handle the complex, varied calculations of a training run. But that flexibility comes at a staggering price. It takes an estimated $150 million in compute power just to train a model like GPT-4. While that upfront cost is massive, it is a one-time, finite expense. It's a high-profile hurdle that often draws focus away from a much more persistent financial challenge waiting on the other side. Once a model is live, it enters the marathon, inference. This is the stage where the model actually works, processing millions of queries from real users every single day. Over a model's lifetime, the cost of inference is 15 times higher than the initial training cost. GPUs struggle here. Their general-purpose design guzzles power decoding instructions, wasting energy on processes unrelated to the actual AI output. The problem compounds with every user. Every real-time interaction and every new feature adds to a daily inference bill that grows exponentially. By 2030, this process will consume 75% of all AI compute, creating a market valued at $255 billion. If the cost per query isn't addressed, these compounding daily operating bills could eventually overwhelm the economic viability of the entire AI sector. To manage these soaring costs, Google developed a specialized alternative, the Tensor Processing Unit, or TPU. Unlike a general-purpose GPU, the TPU is an application-specific chip. It was stripped of all unnecessary flexibility to focus entirely on one thing, the tensor math at the core of AI. This is a systolic array. It acts like an ultra-efficient assembly line, streaming data continuously through the hardware without constantly fetching memory. Eliminating these fetches delivers significantly lower latency, using far less electricity to produce the same result. By engineering a chip hyper-focused on a single task, Google created a system where every watt of power translates directly into more affordable AI. We can see this architecture working in the real world with Midjourney. They recently migrated their entire image generation workload from GPUs to Google's TPUs. Midjourney immediately slashed inference costs by 65%, dropping their monthly bill from $2 million to just $700,000. An Nvidia H100 costs $250 per hour, but a TPU V6e starts at $138. Ultimately, it's a 4 times performance per dollar advantage. That extra capital can be reinvested into research and development, turning infrastructure savings into a massive competitive advantage. Beyond the price of the chip, companies have to consider the total cost of ownership. The biggest bottleneck to scaling AI isn't just the software, it's the massive electrical toll required to keep these systems awake. The physical power draw tells the story. A single TPU V6 consumes about 300 watts of power, while an H100 requires 700 watts, more than double the energy for the same workload. This efficiency is what makes AI sustainability possible. Newer TPU generations have delivered a 3 times improvement in carbon efficiency, reducing the environmental impact as these models scale. Because these TPUs are available on demand in the cloud, smaller startups can access high-end compute without raising millions to build their own hardware clusters. They can simply rent sustainable supercomputing by the hour. Nvidia's GPUs will likely continue to lead in building the most complex models of the future, but TPUs have proven that the ultimate winner of the AI revolution will be the one who makes running it affordable enough for everyone to use.